third graders. Today we're going to start lesson 5 for math. The past 2 days we've learned about division, but we've been solving for the number of items in each group. Today we're going to understand the meaning of the missing number or the unknown as the number of groups. But before we get started with that, let's do some group counting. So we're going to count by twos, and I want you to follow my cursor. We're going to go forwards and backwards, and I'm going to stop in some places and go backwards and then go forwards again and then go backwards again. So you need to make sure you're following my cursor. All right, are you ready? Count with me. 2, 4, 6, 8, 10, 8, 6, 8, 10, 12, 14, 16, 14, 12, 14, 16, 18, 20, 18, 16, 18, 20. Good job. Now we're going to move on to group counting by threes. Same thing. We're going to go forwards and backwards, so follow my cursor. 3, 6, 9, 12, 15, 12, 9, 12, 15, 18, 21, 24, 21, 18, 21, 24, 27, 30, 27, 24, 27, 30. Great job skip counting. Now we're going to do a little review. So here I have an array of triangles. So how many groups are here? Well, I have 2 rows, so we're going to say those are groups. So I have 1 group of triangles and 2 groups of triangles. So there are 2 groups of triangles, and I'm just going to write that here. How many are in each group? There are 1, 2, 3, 4, 5 in this group, and I know since they're equal groups that there's also going to be 5 here. So there are 5 in each group. Now we're going to write this in a repeated addition sentence. So I have 5 here, and I have another 5 here, and that makes 10. So we've got 5 from the first group plus 5 from the second group equals 10, because we know our doubles facts, and 5 plus 5 is 10. Now we're going to write a division sentence for 10 divided into 2 equal groups. We know that when we write a division sentence, our total comes first, and our total number of triangles is 10. So we're going to start with 10, that represents our total, divided into the 2 equal groups. There's 2 equal groups, 1, 2. And our quotient, which is our answer, is going to be how many triangles are in each group. And we've already answered that. There are 5 triangles in each group. So 10 divided by 2 equals 5. All right, so our application problem. Stacy has 18 bracelets. She organizes the bracelets by color. She has 3 equal groups. How many bracelets are in each group? So I want you guys to get your whiteboards and try to solve this problem. And remember, we have 18 bracelets. We have 3 equal groups. And our question is, how many bracelets are in each group? So go ahead and try to solve that. Pause the video, and when you're finished, we'll go over it. All right, so let's go over your work. I used circles to represent the bracelets, and you can tell that I have some blue ones, some green ones, and some purple ones. So I'm going to put them in 3 equal groups. So I'm going to go ahead and draw 1 circle for one group, 1 circle for another group, and 1 circle for another group. I'm going to go ahead, and every time I drag one in, I'm just going to drag one at a time until they're all in a group. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, oops, I put the green one in the blue box, 18. So, I have 18 total bracelets. I organized them in 3 equal groups, but the question asks us how many are in each group. So, the answer to our question is very simple. We can just count how many are in each group. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There are 6 bracelets in each group. So I'm going to type that. There are 6 bracelets in each group. Thumbs up if you got that correct. Great job. All right. So here's our word problem that we're going to work with today. It says, next weekend, my friend Cindy is having a party. Woohoo! 18 people are coming. I told her I'd help her set up tables. We know that 6 people can sit at each table, but we're not sure how many tables we need. So what information do Cindy and I already have? Well, we know that there are 18 people coming, and we know that 6 people can sit at each table. So those are bits of information that are important that we know. We know the total number of people is 18. We know there are 6 people sitting at each table. But what do we not know? Well, we don't know the answer to the question. We do not know how many tables we need, because right here it says we're not sure how many tables we'll need. We do know that there's 18 people coming. We do know that there's 6 people that can sit at each table, but we don't know how many tables we need. So basically, we're going to think of the tables in this problem as groups. So we do not know how many groups to make. So we're going to use these counters to show the problem and check our thinking. We know that we have 18 counters, so I want you to get out 18 counters and pause the video until you have your counters. What we are going to do is, because we know that 6 people can sit at each table, you're going to put your counters in groups of 6. So pause the video and go ahead and do that now. Here are my groups of 6. 1, 2, 3, 4, 5, 6. Oops. 6. There's one group. 1, 2, 3, 4, 5, 6. There's 2 groups. 1, 2, 3, 4, 5, and 6. So these are my tables, and I have 6 people at each table. Looking at our model, what else do we know? Well, now that I've arranged them, I know that we have 1 group of 6, 2 groups of 6, and 3 groups of 6. And remember, we said our groups are really the tables. So we know that we have 3 equal groups. So that means we need 3 tables to fit everybody. So here is our division equation. We have 18 as our total. That's what the problem told us. We divided them into groups of 6. There's 1 group of 6, 2 groups of 6, 3 groups of 6. So we know that we have 3 tables or 3 total groups, which is what our question asked us. We didn't know how many tables we'd need. Now we know we need 3 tables. So let's label our problem. The 18 represents the total number of people coming to the party. We divided that 18 into 6 people at each table, and that equals 3 groups of people, or 3 tables, because we know our groups were actually the tables. We divided the total by the size of the group and found the number of groups we needed, which was 3 tables. Great job. So now let's look back at our application problem, and we're going to compare our application problem to the problem we just did. So our application problem said Stacy has 18 bracelets. After she organizes the bracelets by color, she has 3 equal groups. How many bracelets are in each group? So we know our total was 18. We divided them into 3 equal groups because that's what the problem says. And then our answer was there are 6 bracelets in each group. So our division equation for this problem is 18 divided by 3 equals 6. Then we did the tables, and we started with a total of 18 people coming to the party. We divided them into 6 people at each table, or the number in each group, and we solved for the number of groups, or the number of tables, which was 3. So let's think about how those problems are the same and how they're different. Take a second and think about that. Pause the video. Okay, oops, don't want to draw, I want to drag. So for the bracelets problem, we drew circles to show 3 groups first. Then we shared the bracelets between the groups. So we had the circles, we had 18 of them, and we shared them into 3 groups. For the party problem, we put the people in the groups first, and then we found out how many groups. So the only thing that was different, and I'll draw this out, for the bracelets, the problem was 18 divided by 3 equals 6. And for the party, the problem was 18 divided by 6 equals 3. As you can see, the 3 and the 6 changed places. That's because in the bracelet problem, we tried to find out the size of the groups. We didn't know the size of the groups, which was 6. That's what we were solving for, how many were in each group. But for the party problem, we were solving for how many groups there were, which was 3. We knew that there were 6 people at each table. We just didn't know how many tables to set up. So that is the difference between those 2 problems. We were solving for 2 different things. So let's practice. We are going to look at our problem set, and this one says divide 6 tomatoes in groups of 3, which they did there. There are blank groups of tomatoes. We know that there are 2 groups of tomatoes here, and 6 divided by 3 equals 2. And then in number 3, we're going to divide 10 stars into groups of 5. So I'm going to take these and put them in a group, and I'm going to take these and put them in a group. There are 5 in each group. So 10 divided by the 5 in each group equals 2 groups. Great job today, folks. So what you're going to do now is you're going to go into Seesaw. You are going to complete lesson 5 on Zearn, and then you're going to do your exit ticket for lesson 5. See you tomorrow.